1 by omega c.
1 by omega c. What is the value of omega and what is the value? How will you calculate the
We
value of?
we can write omega as 2 pi f. So f value is given and c value is given also.
Correct. So this was pretty simple, right? I don't think so anybody will be facing any issue. If you have been asked to calculate the impedance, then might be you would have calculated. But okay, that's fine. Reactance you calculate with this formula 1 upon omega c, and whenever you have been asked to calculate the impedance. So see, do not remember anything which one is lagging, leading, anything, right? Whenever you have been given a circuit, you just write like the impedance you should be able to write, okay? And for the inductor, what is the impedance? JXL, right? JXL, correct? And XL is omega L, correct? So that is the impedance. Whenever you have been given, you just write it in the form of like G, like the impedance. So you have, if let's for example, you have been given the resistance and the inductor, you just write it as R plus JXL. Okay, so you don't remember it like whether it will be leading or lagging. Okay, okay, you'll be learning all those the in the like the coming weeks also, but it's better not to remember anything. Okay, like for example, if you have been given the capacitance, if you have been asked to calculate the impedance for whole circuit, if it is a RC circuit, you can directly write it. Don't remember it like whether it's a you'll have to write the J in front of XC and all. So what you can directly write it as, this is a resistance, and then if you have been given the capacitance, right? So even though if you once go through the Laplace, everything will become much easier. But as of now, we have not gone through the Laplace. You'll just think of as you just represent this as R and this as a 1 upon j omega c, and then try to do everything. Okay, because if you just R plus 1 upon j omega c, if you do it, it will become automatically, it will become j minus R minus j upon omega c. Correct. That is basically R plus what? R minus jxl, xc, whatever you want to write it as. And then you can calculate the phase difference with the formula tan theta, right? So tan theta, if you want to calculate it, will become minus xc upon R. Right? So it will be lag or lead. You'll come to know about that. So what I'm trying to say is, even though everything has been derived in the lectures, you don't remember it. You can just go with the, like, you already know the KCL, KVL, okay? So just write the impedance, calculate the, like, all the basic things you know, and with the basic thing only you'll be able to calculate each and everything. So my, like, it's a, like, you should not be remembering. If you'll remember, you'll for sure you'll do some mistakes in any of the questions. So okay, let's move to the next part. So the next part is what? This is also pretty simple. What is this given? The sinusoidal voltage of RMS value 5 volt with the frequency of, okay, if you have been given the RMS, how will you calculate the peak? What is the formula? How do you calculate? Root 2 times, right? How do you calculate
Yes,
the
sir.
peak? Correct. Yeah, root 2 times, if you'll just multiply with the RMS root square, then you'll be getting the mean, you'll be getting the peak value. And then you have been given the frequency also. Again, the frequency has been given, apply to a capacitor, determine the RMS value. So no point of, how will you calculate this? Okay, let's calculate this. How will you calculate the determine the RMS value of the current? Okay, how will you calculate the IRMS? Like Ohm's law. What is the Ohm's law? Can somebody? VIRMS
I is equals to V upon R.
upon.
It says that
Correct.
V upon R. Yeah.
Correct. So what will be the impedance will be there, or 6. This formula I should be using. Correct, because it's just asking the
Yes, sir.
RMS value, so you should not be worrying about the phase and all as of now. If you have to calculate RMS, 5 has been given to you, correct, and then XC you have to calculate it. XC you'll have to calculate again upon 1 upon 2 pi FC, because F has been given to you, correct, and the capacitance also has been given to you, correct. So by
Yes,
this
sir.
way you can calculate the RMS, correct,
Yes, sir.
IRMS. And in the RC circuit, which one lags or which one leads, the current or the voltage?
Current is leads the voltage.
Current leads the voltage, right? Or,
Yes, sir.
and in the RL circuit, what happens?
Current lags and
Voltage leads.
Voltage leads the, correct? Everybody is
Yes,
aware of
sir.
that, right?
Yes, sir.
Yes, sir.
Okay. Now the third one, uh, so basically it happens, you'll be having, and it's pretty simple also. If you have, I'll just give you a brief idea. If you have, let's for example, some voltage source and then the capacitance, this is C. Okay, so how do you calculate the current? I equal to C dV by dt, right? If we'll just write V in the form of, let's say, sine, then this will get, if you'll just differentiate it, it will be in the form of cos, right? And then there will be a difference of 90 degree, and then you'll be having some J that will be applying, correct? And then from there only you'll get that the current, the IC will be leading. So you'll be having some sort of, if you have a voltage like this, your current will be leading by 90 degree, because you'll be getting some J, right? It's not minus J you'll be getting. I hope you are able to understand that. And the same thing happens in the inductor. In the inductor, because you are doing the integration, you'll be getting minus J form, and then the current will be lagging behind the voltage. I hope these all things you already know. So this only, I guess, has been discussed in the lecture. Okay. Now the third question. The third is also pretty simple. The sinusoidal voltage is applied, and this is to microhenry, and then you have in the frequency of the sine wave is 3 kilohertz. Determine the inductance reactance. Okay, the same thing, right? But here also you'll be having two things, right? You can have a reactance and you can have a impedance, right? And the same difference, the impedance is basically you have J times XL, and then XL is what? XL is your reactance, right? What's the formula for reactance? It's pretty simple, right? Omega L. L has been given already.
Yes, sir.
Yes, sir.
So this is also very simple. Mm, okay, so this is like Excel if you have to calculate it, because it has just asked you to calculate the reactance. So you'll be having omega L, omega again you have 2 pi f, and then L has been given already, microhenry, and then you have what? Okay, frequency also is given, right? 3 kilohertz. I don't think so. This will be facing. Okay, now the fifth one is important. Okay, fourth. Okay, fourth salary. In the pure resistor, if you just have resistance, okay, then what is the difference? Phase difference between the voltage and a current? You know, right? In a pure resistive circuit, what happens? Is there in phase difference between a voltage and a current?
No, no, no.
No, right?
In phase.
Because let's say example, you have that there it will be simple, right? V equals to IR, right? So you don't have any difference between that, because resistance doesn't apply any phase, right? Correct? Are you there with me?
Yes, sir.
Let's say example, you have a circuit, simple circuit, and then you just have a resistance, correct? So it'll be, let's say example, VA anything, 0 degree or whatever degree, like any angle you can just give it to it, this. Then the current will be what? Current will be VA, whatever the 0 degree upon R. So this will be VA by R. That'll be a current IA 0 degree, correct? So there is no difference, phase difference between a voltage and a current in a resistive, pure resistive circuit. Okay, that can happen in RLC also, but there again you'll have to check whether it's like in the resonance or not. So, but here, basically, if you just have a pure resistive circuit, okay, then there won't be any difference. The phase difference won't be there between the current and the
Sir, your
voltage.
voice is
Okay,
breaking.
it's breaking a lot. Or is it for everyone or?
Yeah.
Yes, sir. It's breaking.
Okay, just give me 1 minute. Okay, I'll just change my Wi-Fi network. Is it fine now?
Yes, sir.
Okay. So if this is fine, is this fine for everyone?
Yes, sir.
Yes.
Okay. Okay, so we'll try to fasten. Okay. So I guess the fifth one is simple. Now sixth one, we'll go a bit faster. Sixth one is what? How many cycles does a sinusoidal wave go through in a 10 second? When its frequency is 60 hertz. Like, this is much simpler, right? What do you mean by a frequency? And what do you like if it's like in 1 second how many cycle you are following, right? Correct? And
Yes,
then you
sir.
Yes,
have
sir.
a 10 second, then 10 times 60, right? So it's become 600. So
600
no need to
radians.
solve that. Yeah,
Yes,
no
sir.
need to solve that. Correct. So what about the seventh one? Can somebody tell me if you have to write the equation, how will you write the seventh equation? So here it has been said consider a sine wave, okay? That is A lags behind a sine wave B. So let's for example, you're just taking B as something. Let's for example, there's some sine omega t. What about A? Or you can just think of this is 30 degree. Then this will be what? Sine of omega t. Correct? A is lagging, right?
It will
Behind.
be minus 30, right?
No, I'm just adding 30 here, so it will be normal, right? No, so A
Okay,
is
sir.
lagging, right? You got it, right? A is lagging behind the B.
Oh, yes, sir.
You got it right. Okay. So you can just write it as like if you're just writing sine omega 2, you can just write it as sine omega t minus 30 for A. That is also fine. But if I'm just writing for B sine omega t plus 30 because it has a like B is leading with the phase of phi or phi if phi is 30 degree. So A is lagging with 30 degree. 30 degree. So now it has been said consider a sine wave A that is lagging with B by 30 degree. Both signal have peak value as 15. Okay, let's for example. So here you can take 15 as of now here, even though we don't take it normally, but okay, let's find 15 if you are taking sine A is a reference represented as 15. Okay, so here also you have taken the peak value as here it is. So A has been written as 15 sine omega t. So B will be sine omega t plus 30 because you already know that A is lagging with the 30 degree. Now, what you have to calculate, determine the instantaneous value for the sine wave B at 30, 45, 90, 180, 300. So it's pretty simple. You just put omega t equals to 30, 45, 90, 180, 300, and then you'll get the value for whatever equation. Let's say, example, you have been asked to calculate the sinusoidal wave B. Okay, so for B, if you have to calculate, you just write it as 15 sine omega t plus 30, right? And then at what degree? 30 degree, you can just put it
Yes,
as
sir.
30, 45, 90, 180, 300, and then whatever the value that will be getting that will be the instantaneous value. Okay, is it fine to everyone?
Yes, sir.
Yes,
Okay,
sir.
the same thing you have to repeat. The same thing you have to repeat for the eighth question also. Eighth is also pretty simple. You have to just calculate this. You have been given for a sinusoidal current represented as in this form determine the instantaneous value. So it's pretty simple. Now the ninth question is I'm just going a bit faster because okay. So we'll try to just finish all the questions and then we'll go to the practice also. And okay, in the next session, you just try to solve all the practice and the graded. Wherever you are facing issue, we'll discuss that. We'll discuss all the practice. We'll come upon whatever the doubts that you have, any other question that you have, that also you can come up for. Graded also, we can just give you a hint if you are facing any issue in any of the questions. Okay, we'll not be discussing the whole problem, but I can give you some hints so that you'll be able to solve that. Okay, from the graded also, and then try to some. It's like pretty simple, but try to solve some of the questions from maybe gate or from network theory if you're aware, like you can just solve it and then we'll try to discuss if you have any problem there. Okay, so now in a phasor representation, the length of the phasor represents what and the angle represents what? It's like magnitude, right? They call it as magnitude, and the angle
Yes, sir.
represents the phase difference or the phase you can call it as. So cos theta leads by sin theta by what? I guess this is like no need to answer this, like
90
90
degree.
degree. Okay, correct. In a pure capacitive circuit, you just have a capacitor. Okay, the voltage across it. So you already know that, right? In a pure capacitive circuit, what
Current
happens?
leads.
Correct. The IC will be here, right? So it will be leading by 90 degree. Okay, this already I have discussed, right? If you have just this one capacitor, so how do you calculate the capacitance? How do you calculate the okay, can you just please mute? How do you calculate? This is what CB dV by dt, and then if you're just putting it as in the form of VA sine theta, so you'll get it. Like if you'll just and differentiate it, you'll get what IC is equals to C times dV by dt, and V is pretty simple, VA cos omega t. If we'll just differentiate it, what will you get? C times VA, and you'll be getting omega.
Someone is talking.
Can you please mute yourself, whoever is there? Oh. Okay. So this you can just solve it as it is. This is what, if you'll just differentiate it, omega comes out, and then you'll be left with cos omega t, correct? So VA cos omega t. So this is what, this is in leading the sine omega t by 90 degrees. So you can write it as it is, so omega c VA, and then because it is a cos theta, you can just put it as 90 degree because it is leading the sine by 90 degree. So this you can just write it as, and this also you know, right? 90 degree what is what, so you can just write it as j omega c VA, and this is what VA upon 1 upon j omega c. That 1 upon omega c you can just write it as xc, okay, and the 1 upon j omega c is basically the impedance of the capacitor, right? So here, from here also you can just see that this is leading by 90 degree, okay, so IC is leading by 90 degree for as compared to the voltage that you have across a pure capacitive circuit. So here also the IC will be leading, the current will be leading by 90 degree. Now the next problem, the real and the imaginary part of the impedance respectively are referred as a name what? The real and the imaginary part. Okay, so the real
Reactance.
part, reactance or resistance? This is resistance, right? And this is reactance, I guess. Okay, so we'll be having, so for any circuit we'll be having what? R plus J whatever X, correct? So this will be
Yes,
what? The
yes.
imaginary part will be reactance, correct? And this will be a resistance. Okay, I hope this is clear.
Yes, sir.
If you have a J, I already told you, if you have a J operator, that means that it is represents 90 degree, okay, because you already know that this is a real circuit and then this is the J1. So if you have something that is multiplied with J, basically that is leading by 90 degree, okay. If you have something in the minus J, that is for the XL, it means that it is lagging behind by the 90 degree. I hope these are all the basic things, but okay, that will help you in solving some of the problem from the graded all. Okay, so whatever the next one, the impedance of the RC circuit. What is the impedance of RC circuit?
Minus JXC.
Correct, R minus JXC, correct. I already told you, you can just write it as R plus J, sorry, if you have been given the resistance, and then, so what is this? 1 upon J omega C, and this is what? R. If you'll just add it, R plus 1 upon J omega C, okay, then you can just multiply J square here, so J will get cancelled, sorry, minus J square, because minus times minus 1 will be 1, right? So you will be left with what? R minus J upon XC, sorry, omega C, that is basically XC, correct? R minus J upon omega C. If you want to write it as in the form of a reactance, it will be R minus J XC. Is it clear to everyone? How did we wrote this? R plus 1 upon the impedance for the resistance and 1 upon J omega C. If we'll just add it out, R plus J, sorry, 1 upon J omega C. Okay, this is what the exact value is. If you want to write it in the form of a like a real and imaginary, what you have to do is just try to put J in the numerator, right? How can you write it? 1, how can you write this one can be written in the form of minus times minus 1, right? And minus 1 you can just write it as J square. So J will get cancelled. They will be left with what? R minus J upon omega C. And 1 upon omega C, you already know that is the reactance of the capacitor. So that will be R minus J XC. Is it clear to everyone?
Yes, sir.
Yes, sir.
Correct. Okay. Now, whatever the impedance of the pure resistive circuit, I hope you don't have to write anything for that. This basically just have the resistance, so nothing else. Whatever the impedance of a pure capacitive, so you just have a capacitor, nothing else. Then what will be the value? Minus
JXL.
JXC, right? Capacitive circuit, right?
Oh,
So you
yes, sir,
just
yes,
have
sir. I think about
capacitors. So this
17th
becomes
question.
1 upon J omega. Okay. Okay. The impedance of a pure inductive is what? JXL. Correct? Because you just have
JXL.
correct. So this is what? J times omega L. So this is JXL. Whatever the impedance of a RL circuit. RL circuit what? R plus
R
JXL.
plus JXL.
Correct? You have a resistance. Okay. So you have this one. This is resistance and then this is XL. Correct? Or you can just write it as J omega L. Correct? So R plus J omega L. You can just write it as R plus J XL because XL is your omega L. Okay, so what I will do, I'll just solve it also nicely and then upload it in the portal so that if somebody is having an issue, you can just go through that. But as of now, we'll just be solving roughly. Okay, after the session, I'll just solve it and then upload also. Okay, what about the 19th? The 19th question. What is that? The find the magnitude. You have to calculate the magnitude of the impedance and its phase angle in degree. If you have a RL circuit has a resistance 33 kilo ohm and the inductive reactance of 50 kilo ohm, how will you solve it? So inductive reactance has been given. That means what? I've been given XL or the impedance. So XL has been given, right? 50
Yes,
kilo ohm
sir.
has been given to me. Correct. Now you have to find the magnitude of the impedance. How will you calculate the magnitude? You already know that how to calculate
Root.
if you have been written.
R
Yeah.
square plus XL square square root.
This is the impedance, correct? The whole impedance of the RL circuit, correct? Okay, yeah. So if you have to calculate the magnitude for any vector, how do you calculate? Under root of R square plus XL square, correct? So R has been given to you 33 and then this is 50 and the unit also you can see that kilo ohm, so no problem, you can directly do it like this 33 ka whole square plus 50 ka whole square ka under root. Okay, and how will you calculate the phase? Phase, how do you calculate? The tan theta of
Tan
tan
inverse
phi is
XL
equal
by
to what?
R.
On X.
Correct. So you can calculate it as tan inverse XL by R. Okay, I hope there's no problem in that. Whatever the next question, the 20th one. In a R circuit, the voltage across the resistance the inductor has been given to you. What is the magnitude of the total voltage across the RL? The same thing, right? You have
Yes,
been
sir.
given. See, correct? Again, the same thing, right? You have been given 2 and the 3 ohm respectively. What is the magnitude? So if you have to calculate the magnitude, you'll again do the same thing. 2 ka whole square plus 3 ka whole square. Correct?
5.
Yes, sir.
Right? So whatever the answer that will be
Yes, sir.
getting.
5.
Now what about correct? When a frequency of the applied whatever it's been given, the frequency of applied voltage in a RL circuit is increased, what happens to the inductive reactance? So inductive reactance, so you already know that XL is proportional to
Increase.
omega L, right? If you are increasing the frequency, it will increase, correct? Okay. Now AC
Yes,
circuit,
sir.
AC current has been given, yeah, correct. So AC current has been given in the form of RMS, okay, at frequency has already been given, flow through a inductance of 10 microhenry, and then the voltage drop across the inductor is what? How will you calculate this? So this, how do you calculate? V equals to what? IRMS
V
times
equals
XL,
to IR.
correct?
IXL.
Correct. So correct. So IRMS has been given to you. XL is pretty simple. You can just calculate 10, 100 microampere, and then you have to multiply with omega L. Omega is what? 2 pi F. So F value has been given to you already. Just put the value, and L also has been given. Inductance is also given. You can calculate it. I hope there is no difference. Like, I don't think so. Any problem till now. What about the next one? The next question, V1. So you have been given the voltage V1, V2, V3. Okay, this 3 has been given. Now you have to tell me V1 leads by V2. which one leads, V1 or V2? So if you have V2, V1
V1.
will be like this, correct? With the angle of 15 degree. So V1 is leading, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Correct. What about the V3? V3 is somewhere here. No, that you don't know because, yeah, V3 is somewhere else. It's lagging. Okay, so V3 is lagging with the 10 degree from. Okay, you can just think of as this as sine omega t. So this will be sine t plus 15, and then this will be omega t minus 10. So this is lagging, this is leading. So V1 is leading, V1 is leading with respect to V2, and V3 is lagging with respect to V2, or V2 is leading with respect to V3 by the angle of 10 degrees. So I hope the first one is correct. I guess not any other is correct. Yeah, so A is correct. I don't think so. B is not correct. Both V1 and V2 lags behind. No, this is also not correct. Both V1, V3, V1 and V3 lags. This is also not correct. Okay, so only one option, the A is correct. What about the 24th question? What has been given here? So in a certain RLC circuit, R has been given to you, XC, XL, everything has been given. What is the magnitude of a total reactance and the total impedance? How will you calculate the total resistance? This is pretty simple, right? How do you calculate the magnitude of total reactance?
It's square root of XC square plus XL square.
No. So how do you calculate that for the RLC circuit? If you have been given R, and then okay, what is the value that you'll be getting in the end? The total impedance, okay, I can understand. You just have to write it in the form of, right, this one, Jx, correct? This will be the reactance, and this will be basically the real part, the imaginary part, right? So first of all, you should be getting this imaginary part, correct? And how will you get this? How will you get that?
It's XL minus XC.
Sorry, sir. Can
J
you
times?
repeat?
No,
XL
what I
minus
was trying to
XC.
say, if you have a RLC circuit, right? If you have been given a RLC circuit, so R has been given L and C. So you'll be having R, and then this will be what? J X L or J omega L, and this will be what? Minus J times upon omega C, correct? So you'll be left with what? R plus J
So the
omega
impedance
L
will be
minus J
R square.
upon omega C, correct? So it will be what? J times, this is XL, right? Minus XC, correct? If you have been asked to calculate the total reactance, so this is total reactance, right? XL minus XC, are you there?
Yes, sir.
If you have been asked to calculate the total impedance, then impedance you can calculate it as R square plus XL minus XC ka whole square, correct? So this is what from the starting I'm telling you, right? If you have been asked to calculate the reactance is what? The imaginary part that you calculate, right? And then if you have to calculate the impedance, that is like the magnitude that you have to calculate. So you just write it in the form of real plus imaginary first of all, okay, and then you can calculate like this. This is the whole impedance of your circuit, RLC circuit.
And sir, the reactance is XL minus XC, right?
That is XL minus XC. That you can directly see it, right? If you have to write it, this RLC circuit, okay, normally in the form of a real plus imaginary, right? I just wrote it. This is what? R plus J omega L minus J upon XL, correct? And that if I have to write it, R plus, I'll just take the common J here, so it will be left with omega L minus of 1 upon XL. You already know that omega L is what? The reactance of the inductor, right? XL.
Inductor.
And then 1 upon omega C is what? XC. Oh, correct? That is the reactance
Yes.
for the capacitor. So you can just write it as it is. So this is for the RLC circuit. Okay. And then if you have to just calculate the reactance, you can directly XL minus XC. That will be the reactance of the imaginary part. And then if you have to calculate the impedance, then you have to do under root of R square plus XL minus XC ka whole square. Clear?
Yes,
Clear to
sir.
everyone?
Yes, sir.
Yes, sir.
Okay. Now the next part is you have been given some voltage. Okay. Now you have to calculate all those part and this. Okay. Now what is the phase for this? The voltage that has been given to you.
10. 10.
10 degree. Okay. What is the amplitude? Amplitude is
12.
12, correct? Phase is 10 degree. Angular frequency, what is that
50.
angular frequency?
50.
50, right? Angular
50.
frequency is omega, correct? And
Yes,
this is
sir.
what?
Yes.
The linear
Yes.
frequency is f naught. This is the angular frequency. If you have to calculate the time period, how will you calculate? How do you calculate the time period? 2 pi upon omega,
2
right?
pi
2
upon
pi,
omega.
okay, or omega, whatever has been given to you. So 2 pi upon the value that is given 50, correct? And then if you have to calculate the frequency, what is that? 1 upon t,
2 pi.
1 upon t.
correct? So this you can calculate it as or omega naught upon 2 pi is frequency. You can calculate it for the 25. So this is pretty simple. And then again the same thing, you can calculate it for the 26. Let's move to the 27th. 27th, V1 is been given to you, V2 is been given. Now you have to calculate the phase difference between these two. How will you calculate the phase difference between these two?
First, we will draw it in phasor, then we'll calculate it.
Okay, you can calculate it, right? If let's for example this is V1, okay, so this is V2. The difference between these two is what? 30 degree, correct? So
Yes, sir.
Sir, I have a doubt.
yeah.
Yeah, is it asking about the magnitude of the phase difference, or I need to include the sign also?
No, I didn't magnitude ka phase difference. I didn't get that point.
No, like if V1 is the reference, then it will be 30 minus 60, right? So that will be minus 30.
But V1 is the reference. Okay,
Yes,
yeah,
if
I
V1.
just took it V1 as a reference. Then V2 will
No,
be.
if V2 is the reference, then the phase difference will be 30 minus 60.
So if V2 is the reference, right? So V1 is what? V1 is lagging, right? So V1 will be somewhat like this, right? So V2 is always be leading, correct? Did you get an idea? Or? Have you understood or not?
Sir, don't we have to calculate the angle from the reference point? If I
Okay.
calculate the angle from the reference point, then it comes out to be negative.
No, see, even though determine the phase difference between these two, use V1 as a reference. Okay. So if you let's for example, you're just taking V1 itself as a reference. Okay. If you have a V1, this
Okay,
is what
so it's
you got it.
given that V1 is the
Yeah.
reference. Sorry, I
Uh-huh.
didn't see that.
Okay. What about the 28th, the peak value for a sine wave? Okay, this is fine. 29th, the phase represent. Okay, this you already know, right? How to calculate the peak and all. This like just divided with root 2 to get the RMS and multiply with root 2 to get the peak. Okay. So what will be the value? This is 5 upon root 2. In a phasor representation, generally the positive angle are measured in the counterclockwise direction from the 0 degree. Okay, so the how do you calculate? The counterclockwise only, right? It's correct, right?
Yes, sir. Yes, sir.
Yeah. What about the 30th question? The evaluate if A has been given to you, B is also been given, and then C is given. Evaluate A by B plus C in the form of. Okay, that's how will you do that? Okay, first of all, how will you write this C?
So we have to
This is what?
convert it into
Sir,
rectangular form.
Correct? 10 cos theta.
no, the first one is A by B, so we
That's
have
right.
to use
10
the
sin theta, right?
angular form for A and B, and then we can use the rectangular
That also
form.
you can do, even though correct. You can write the C in the rectangular, or you can write the 10 and A and B in the polar form, and then you can calculate it. Anything is fine. You can just write C also in the form rectangular form and then calculate it. Correct? If you'll just do A by B. So I guess if we are dividing it, it's better to write it in the form of a polar itself, and then you can just write it. Or let's for example, I can do it in this form also. I have to do what 10 A upon B, right? So 10 plus J 5J upon what is this minus 3 plus 4J. How do you calculate? You can just multiply with minus 3 minus 4J. minus 3 minus 4j. You'll get it. Or whatever he said is a better way to calculate it. Just to write it in that form. Correct?
Yes, sir. First in polar form, then convert it to rectangular.
Correct. Yeah, you write everything in the polar form. A, B, C is already been given in the form of a polar side. Calculate the magnitude and then the angle. So 5 upon 10. So, but again, there will be a much of calculation, but that is fine. You'll have to do the calculation. Here also, you can just convert the angle. You can calculate the phase. First of all, 4 minus 4 upon 3, the tan inverse of this. For this also, you can calculate. And then a upon b, then a upon b will become much simpler, right? But again, a upon b, whatever you are getting, again you have to do whatever you will be getting a upon b, then convert that into a rectangular form, and then you have already c in the form of a rectangle, like you have already converted here in the form of a rectangle, and then you can do a upon b plus c. I hope you'll be getting the answer. Correct? Any doubt, anyone?
No,
No,
sir.
sir.
Okay. What about the next one, the 31st one? How will you solve the 31st? You have been given two signals, right? V1 and V2 has been given and connected in a series. Okay, this simpler. No. What about the next question?
We can
Express this. Yeah. Okay, 32 also. It's like you have been given the V1, magnitude of V2. How will the magnitude of V1 determine the phase angle of V2? How will you do that? 32.
we will change it in polar. Then do the calculation.
Okay, so 32. Okay, let's. If V1 is then given to you 100, 10 degree. V2 also the magnitude has been given as 140. The phase is not there. Now the magnitude of V1 plus V2 has been given 120. Determine the phase angle of V2. How will you do that? Can somebody tell me how will you do this?
Yes, sir. By
It will be a
fixed
lot
angle.
of calculation. Correct? See, for this problem, which one was this? 32, right?
Sir, we can solve it by a vector using vector.
Correct. You
Vector.
can use the vector wala concept. Correct. So you can just do it like this because V1 plus V2 has been given, right? So you can just think of as you're just adding two vectors. Correct. So adding two vectors is what? Whole square plus V2 ka whole square plus 2 V1 V2 5. So this 5 will be the phase difference. Correct. Add there, and this will be what? V1 plus V2 ka whole square. So this will be 120 ka whole square, and then you have V1 ka magnitude you already have, V2 ka magnitude you already have, then 2 times V1 V2, and this cos 5. This cos 5 will give you the phase. Correct. So 120 ka whole square. What is the value of V1 ka whole square? V1 is 100 ka whole square. Then V2 is what? 140. Then 2 times
Yes, sir.
V1 100 into 140 into cos 5. You can calculate the 5, right? 5 will be whatever the value that you are getting, 120 ka whole square minus of all these things, 100 ka whole square plus 140 ka whole square minus 140 ka whole square upon 2 times 100 times 140. This is cos inverse of this value. Whatever the phi you'll be getting, that will be the phase difference. Is it clear? I guess this is just the calculation, not much
Yes,
of
sir.
concept, right? Okay. What about the next problem? You have been given you have to express this 3 sine 20t plus 10 degree minus 5 sine 20t minus 30 degree in the form of a sine omega t plus 30 theta. Okay, so what you can do is you have to convert that everything in the form of a sine, right? Okay, then it's fine, right? If you have to convert just in the form of a sine, how will you do that? Just try to put everything in the form of one phase. How will you do that?
By the formula sine pi by 2 minus 5.
Which one? Sine?
Pi by 2 minus 5 is equals to cos theta.
No, from there also, I don't think so. You'll be able to write it. So this is what? This is 3 sine 20t plus 10, and this is minus 5. Okay, so I don't think so. We'll have to use the other method, I guess.
Sir, we
So
can
there was a
convert the
Which formula?
we can convert the second sign to cos and then use the a sine x plus b sine y formula.
Okay, that you can do it.
A sine
A,
theta plus b sine theta.
yeah, that you can do, but
B
I guess
a
that
sine
also
theta
will be
plus
a
b
lot of
cos theta.
calculation. I guess there must be
But
some
we
other
can
method to
also
solve.
do this using the Euler form.
Mm, yeah, that also you can do, but I guess there must be some other. We will have to check. Okay. You can use that method, but I guess that will again a calculative, right? If you're just using a sine theta plus use that method also, there is a lot of form. I don't think so that formula is needed. Is there any other method that you can solve? I guess so.
So can we do it by
Because
dividing by root of 3 square plus 5 square, then convert it into cos phi?
We use
yeah,
vector.
that
That's
you
what
can use. Yeah.
exactly say sine theta plus b cos theta is doing.
Yeah, that is what I. So the formula again that will be again under root of a square plus b square minus 2ab cos x minus b. So that you can solve it. Is there any other better way? Because or it is calculative only. There is no any other way to solve it. Because the second one you can just try to convert this in the form of a sine and then maybe it is doable. But the 33,
Yes, sir. We can do it by a using vector addition.
huh, yeah, vector we can do. Yeah, correct. Vector method we can do it.
But it is quite difficult to
Correct,
solve.
correct. It's yeah difficult to solve. Mm. Okay, I'll just check this 33. Maybe in the next session, I'll try to come up with some other method to solve it. As of now, you can just think of as like the normal method. Like you can just use the vector wala thing a sine x minus b sine. So you can just try to solve it as it is. Like let's for example a sine x minus b sine y, and you have that formula right? A square plus b square minus 2ab cos x minus y. X you can just try to put it as 20 t plus 10, and this is what 20 t minus 30. So that method is there, but that will be a bit difficult to calculate, I guess. Okay, let's see this 33. I'll try to come up with the other method, or if you have any other method, you can just let me know in the next session. Whatever the other question, the next one.
Sir, in the 33 question, can I do like this 3 sine to 20t plus 10 minus 3 sine 20t minus 30 and then add a minus 2 sine 20t minus 30 and then use sine c minus sine d formula?
That also you can do. Correct. Sine a plus b and then sine a minus b. But in the end, whether you'll be getting everything in the form of a sine only, I guess the cos will also come, right? Then you have to okay, you can do it like you can convert that sine into cos and then try to do it, right?
Yes, yes.
Yeah, that also can work. Like you can just use the formula a plus b sine a plus b sine a minus b, right? Try to expand everything, and then wherever you are getting the sine, you try to convert that in the form of a cos. But again, there is an issue. Uh, if you are not getting the okay, so we'll have to put everything in the form of sine omega t plus omega t is fine, will be same everywhere. Mm, 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 mm. Okay, we'll see this. Okay, okay, let's drop this. The 33 and 34 we'll try to solve it in the next session. Okay, that is left. Now, what about the 35th? The impedance of the RLC circuit is minimum at series resonance. Is minimum or maximum? Minimum, right? The current will be maximum, correct? right? If you have RLC circuit,
Yes, sir.
right? If that RLC circuit has the resonance, series resonance, then you'll be left with what? There'll be a totally pure resistive, right? Because the reactance will get cancelled, correct? So you'll be having I will be V upon R, because this part will be cancelled, right? Omega L minus 1 upon omega C, this will be cancelled. So this will be the minimum. The denominator part will be minimum, that means the impedance will be minimum, the current will be maximum. So the impedance will be minimum. That's the correct statement. Okay? Is it clear to everyone? So what? Okay, so 2-3 more
Yes,
questions
sir.
that will be solving in the next session. But as of now, if you have any doubt, yeah, 33, 34 will be solving again. I hope there must be the other method. Otherwise, it will be very calculative. Any doubt that you faced in any of the question? I don't think so. There was much to be discussed. Like any question that would have troubled you. Only the 33th question that was a bit calculative. Other than that, we have discussed it